I am Anil Kumar. Welcome to my series on inverse trigonometric functions. We are going to take up reciprocal functions in this particular video. In case you want to learn from me, you can always send an email on the address given here. We are uploading new videos on our website. Please check all our new videos and opportunities to learn on one-on-one sessions with Zoom. We'll now discuss how do we find inverse of cosecant function, inverse of secant function, and inverse of cotangent function. We'll work with these inverse to find the principal value and also check what happens when we have combination of these functions. We'll also look into the domain of inverse function. Like always, you have to always refer to these special triangles. The triangle pi by 4, and pi by 2, and the other one pi by 3, pi by 6, and pi by 2. These triangles help you to find the values for the inverse functions. We have also shown you the graphs for the cosecant, secant, and cotangent along with their inverse. So the graph of cosecant function is given there. As you can see, it is a periodic function, right? So you need to restrict the domain of this particular function so that we could have inverse as a function. So we restrict the domain from minus pi by 2 to plus pi by 2, not including 0, of course, right? So that becomes the restricted domain. For this restricted domain, we'll have the inverse as a function. We'll call these values as the principal value. The inverse is shown here in the diagram below. So earlier, theta was your independent variable. Now when you do the inverse, x becomes the independent variable. Theta becomes dependent on x for the inverse function. So that is a major change, as you can see. Domain and range will also swap. We're going to look into these details in this particular lesson. Let's begin with the cosecant function and understand how does it work. So as I was saying, for the cosecant function to have an inverse as a function, we need to restrict the domain. As far as cosecant theta is concerned, then we know that cosecant theta will always give you a value. Let us call this value as x. Now, domain for cosecant function, which we are restricting, is from minus pi by 2 to 0 and from 0 to pi by 2. Well, the function is not defined at 0 and therefore it is excluded from this particular domain. The range, as you can see, is all real numbers minus 1, 1. What does that mean? Well, it really means that the range is that the x values are either less than equal to minus 1 or the x values are greater than equal to 1, right? So union. So that is how we can say the range of this particular function. Clear? The graph on this side indicates the range, as you can see, for the inverse of the function. And here, the range for the function itself. Is that clear to you? Perfect. Now, when we swap x and y, we get the inverse. So for the restricted function, which is within this particular domain without including the 0, we have the inverse as a function. So we know that the cosecant theta is decreasing in the interval minus pi by 2 to 0 and from 0 to pi by 2, as you can see here. So it is never turning in this area. Perfect. Therefore, its inverse will be a function. We'll write that function as cosecant inverse x. You could also write this as arc cosecant x, right? The value returned will be the angle in radians. So always theta, the angle, will be in radians. Now for this particular function, the domain will be all real numbers except for those between minus 1 and 1, and the range will be from minus pi by 2 to 0, 0 to pi by 2. The function is shown here in this other diagram. Correct? So in this particular case, you can see that earlier theta was along the x-axis. Now the output or the result is theta for any value of x, right? So for the inverse of the function, the domain now will be less than x less than equal to minus 1 and x greater than equal to 1. So the domain and range actually swaps, right? So that is for cosecant theta, and this is for cosecant inverse x, as you can see, right? Now, there is a maximum and minimum value for this particular function, as you can see. For the inverse function, cosecant inverse x, it is decreasing in the interval from minus infinity to minus 1, 1 and minus 1 being included, 1 to infinity. Maximum value is at pi by 2, and the maximum value is x equals to the maximum value is pi by 2 at x equals to 1. The minimum value of cosecant inverse is minus pi by 2, and that is at x equals to minus 1. So this is the minimum value for us. So that is the minimum, and this is the maximum. Perfect. Now, based on this information, let's have a few practice questions. I'd like you to read the question and answer them, and then also look into the solution. So the very first one here is, what is cosecant inverse of half? Well, half is somewhere in between, right? Between plus and minus 1, and therefore it does not exist. Since the domain of the inverse function is all real numbers except for the numbers between minus 1 and 1. Clear? Now, you will also notice here that the values which we are going to get as answer will either be in quadrant 4 or in quadrant 1, right? So if I am trying to find the inverse of a negative number, I expect the answer to be in quadrant 4. I mean, negative, right? If I'm looking into a positive number, the answer will be positive. So let's see. Cosecant inverse 2 over square root 3 is positive, so the answer is positive. Now, we can go to the triangle, which is a special triangle, and then we can find the value, correct? So in this special triangle, we know for different angles, let's say this is pi by 3, that is pi by 6, 2, 1 and square root of 3. Now, we can clearly see that cosecant inverse of 2 over square root 3, we're talking about these two sides, should be equal to what? It is pi by 3, right? So that is how we could actually find these solutions. Now, if this is negative, the answer has to be negative. Cosecant inverse negative square root 2 will be negative pi by 4. So I hope that helps, right? Cosecant inverse negative 2, negative means the solution is also negative. Negative pi by 6 is the right solution. Cosecant inverse negative 1, that is the basic minimum value, which is minus pi by 2. Cosecant inverse of 1 is the maximum value at pi by 2. Perfect. Now let's look into secant function. For secant theta, as you know, the domain is from 0 to pi by 2 and from pi by 2 to pi. If we restrict this domain in this particular interval, as we have shown here on the graph, right, this particular interval without including the pi by 2, then the inverse is a function, right? Basically, you know that the secant function is a periodic function. So you need to restrict the domain, and therefore we're talking now about restricted domain. That ensures that the inverse is a function. So the restricted domain is given to us as 0 to pi by 2 to pi by 2 to pi. For this restricted domain, the range is, of course, all real numbers without including the numbers between minus 1 and 1, right? Now, inverse of this function will have the domain and range swapped, correct? As you can see, now the domain of the inverse function will be all real numbers without including minus 1 to 1 values, and the range will be from 0 to pi by 2 union pi by 2 to pi. So now let's look into the characteristics. Secant theta, as you know, is increasing in the given interval from 0 to pi by 2 and then from pi by 2 to pi. Well, if I write the complete interval, then it is not decreasing, right? It's kind of very important to understand the term in between that and, right? So when you split this two, then it is decreasing within the given interval. Now secant inverse theta, domain and range swap, but it is always increasing. As you can see, the function is always increasing in its domain from minus infinity to minus 1 and from 1 to infinity. It does have a maximum value and a minimum value. The maximum value is pi at x equals to minus 1, as you can see here. The minimum value is 0 at x equals to 1. So all the results will have positive sign. What you notice is the given value could be in quadrant 1 or in quadrant 2. Since we have restricted our domain to 0 to pi by 2, right? That makes it quadrant 1. And then from pi by 2 to pi, that makes quadrant 2. Perfect. So let's calculate some values. The first one here, secant inverse minus half. Well, that is not in the domain and therefore it does not exist. Secant inverse of 2 square root 3, you can always make your special triangles to help you answer these questions. The solutions are given here. You can do and then check with these answers. So pi by 6 will be secant inverse 2 square root 3, and for secant inverse minus 2 over square root 3 is 5 pi by 6. Let's look into this. So basically, when you're saying a negative value, you know the cost rule, right? Now in this quadrant, we know secant is negative, right? So secant is negative in this particular quadrant. Now, since it is negative, you can see this value negative here, right? So we are expecting the angle to be in this particular quadrant, correct? So that is why we are getting this value of 5 pi by 6 for minus 2 square root, 2 over square root 3. You get the idea. So that is how we have to figure this out. So you can actually make this special triangle. Once again, let me just do it for you. And then from here, we'll continue. So if this is pi by 3, sides are 1 to square root of 3, and this is pi by 6. We're looking into secant value of 2 over square root 3. So 2 over square root 3 is this combination, right? 2 over square root 3. So that means the angle is pi by 6. Now this pi by 6 is the acute angle in quadrant 2, and therefore the value should be 5 pi by 6. You get the idea. So that is how you get your solution. Now secant inverse minus 2. So minus 2 means this over that, and we are looking into pi by 3. Now because it is minus, we are looking for this angle as pi by 3. So if this angle is pi by 3 here, then the angle which we are talking about is 2 pi by 3, and therefore that becomes the solution. Is that clear to you? Secant inverse of minus 1 is the absolute maximum value, which is pi, and secant inverse of 1 is the absolute minimum value of 0, and that is how we can find the values. Now let's talk about the cotangent function. The cotangent function is sketched here. You know it is periodic as shown here. To find the inverse, we'll definitely have to restrict the domain. So we are restricting the domain of cotangent function to 0 to pi. Within this, it can have all the real numbers as its range. So to find the inverse, we can swap the x and y values and sketch a graph which looks like this. It is a continuous function within the domain of all real numbers with the maximum value approaching pi, minimum value approaching 0. So in this particular case, cotangent inverse x has a domain of all real numbers and the range is from 0 to pi, both not included. So this function also does not have any maximum or minimum value. Be clear about it, correct? Now coming back to the characteristics, cotangent function is a decreasing function in the interval from 0 to pi, both not included. Cotangent inverse is always a decreasing function in all real numbers. And if we have a combination of cotangent inverse of cot theta, we'll get theta only if we have the angle within 0 to pi, right? Within this interval. And cot of cot inverse x will always return you the value of x for any real value. For all x belonging to real numbers, the value of cotangent inverse x is always between 0 and pi. So here are a few examples. You can pause the video, copy these questions first, and then write down the answers, check with the given answers. Correct? You might need to sketch your diagram for pi by 6, pi by 3, pi by 2 triangle, and pi by 4, pi by 4, pi by 2 triangle. These special triangles will help you get the result. So first one here is cotangent 0, and that gives you the value, which is pi by 2, right in the center here. Cotangent 1 over square root of 3. When we talk about 1 over square root of 3, then in that case, we are looking for a value, which is 1 over square root of 3. So this particular combination gives you the answer as pi by 3. Cotangent of square root 3. So square root 3 is square root 3 over 1. That gives you pi by 6 as the solution for cotangent x. Now, when we talk about cotangent inverse minus square root 3, in that case, we are in quadrant 2. So in quadrant 2, we are looking for an acute angle. Cotangent is square root of 3 means this. So we are looking for an acute angle pi by 6. So that gives you, let me just sketch this here. That will be the solution, right? This will be the solution. But that minus pi by 3, you can also go with the acute angle, which is pi by 6, correct? And therefore, the answer is 5 pi by 6 as shown here. So you have to be careful when you're working with the negative values. Cotangent minus 1 is the value 3 pi by 4, right? So again, that is the solution. Perfect. Cotangent inverse of minus 1 over square root 3 is 2 pi by 3. A small practice on this will help you understand how do we find the inverse of cotangent functions. Now let's take up some examples based on how do we calculate the domain of such functions. The very first example on domain here is find the domain of secant inverse 2x plus 1. Okay, so that is a typing error. Fine. So let's see how to find the domain of secant inverse 2x plus 1. You know the secant x domain is that the secant inverse x domain is that the x values are either less than equal to minus 1 or greater than equal to 1. Now for 2x plus 1, we'll put the same condition. So 2x plus 1 should be either less than equal to minus 1 or should be greater than equal to 1. We are going to solve these two inequalities separately to get our part solutions. So 2x plus 1 less than equal to minus 1, bringing 1 to the other side gives you 2x is less than equal to minus 2. Dividing by 2, we get x is less than equal to minus 1. On the other hand, 2x plus 1 greater than equal to 1, taking 1 to the other side gives you 2x greater than equal to 0. Dividing by 2, x greater than 0. So that becomes the domain for the given function. Perfect. Now let's try to evaluate some trigonometric functions involving inverse of these reciprocal functions. Find the principal value of each of the following. The first one here is secant inverse minus 2 minus tan inverse square root 3 plus 2 times secant inverse minus 2. Part B is we have to find the principal value cot inverse minus 1, secant inverse 2 over square root 3 and cosecant inverse minus square root 2. You can always pause the video, answer this question and then look into the suggestions. So let's write down one by one. So for the first one, which is secant inverse minus 2 minus tan inverse minus square root 3 plus 2 cosecant inverse minus 2. What is secant inverse of minus 2? Well, that is 2 pi by 3, correct? Tan inverse of square root 3 is 2 pi by 3. Now this is minus, we wrote minus, plus cosecant inverse minus 2. So that is minus pi by 6. Since it is multiplied by 2, we'll multiply by 2. Evaluate this expression, simplify it to get pi by 3. So that is how you could do it. The next, cot inverse minus 1. Well, cot inverse of minus 1 is 3 pi by 4. Secant inverse of 2 over square root 3. So the negative sign, and secant inverse of 2 square root 3 is pi by 6. These triangles really help, right? So this is helping you out to get the solution for this. Now, cosecant inverse of square root 2 is basically pi by 4. Minus gives you that minus sign here. Now you can take a common denominator 12, simplify to get 4 pi by 12, which is pi by 3. And that is how you could evaluate these expressions. The last example here is to relate a trigonometric function. Question is, find an equation for the inverse secant function y equals to secant inverse x in terms of cos x. So we'll write the secant inverse x in terms of cos x. Let's begin with y equals to secant x. Now, to find the inverse, what do? We swap x and y. So when you swap x and y, you get x equals to secant y, right? So we are trying to find the inverse. So first step is to swap. Now, secant y is written in terms of cos y as 1 over cos y. Then we cross multiplied, got cos y as 1 over x. So y is cos inverse of 1 over x. So we can write that secant inverse of x is same as cos inverse of 1 over x. Very important formula which will help you later. I hope this makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. You can always send me an email with your feedback, and in case you want to learn from me, we can work out a plan with you. Thanks for your time and all the best.